We are now going to discuss rain-man problem using the concept of relative velocity. It has been observed that at the time of rain, when there is no wind, the person should stand with his umbrella normally. But when the same person starts moving with a considerable velocity, that is the velocity comparable to the velocity of the rain, then the person should hold his umbrella at a certain angle with respect to vertical in the direction of his motion in order to protect himself from rain. And why he has to keep his umbrella at a certain angle, this will be analyzed in this problem. Okay, so be there with me. After this explanation you will get to know about this thing. We suppose that rain is falling vertically downward with velocity Vr and the man is moving towards right with velocity Vm. When the man observes the motion of the rain, that motion will be the relative motion because the man himself is in motion. Relative velocity of rain with respect to man will be actual velocity of rain minus actual velocity of man. Understood? This expression can also be written as Vrm is equal to Vr plus minus Vm. So Vrm is the resultant of Vr and minus Vm. So you have to take minus Vm. Say this is minus Vm. After that we have to draw one rectangle and the diagonal of this rectangle will be the relative velocity of rain with respect to man. So at the time of motion, the man will find the rain falling at an angle theta with respect to vertical, not in vertical direction, and hence the man should hold his umbrella at a certain angle in order to protect himself from rain. Suppose these are the raindrops and this is the handle of the umbrella, and this is what, this one is the umbrella. Understood? So this angle will be theta because these two angles are vertically opposite angles, and what will be this angle? This will be 90 degree. So now the magnitude of relative velocity of rain with respect to man will be square root of mod Vr square plus minus mod Vm square plus 2 mod Vr mod minus Vm cos of the angle between minus Vm and Vr, that is 90 degree. So what we will get, Vr square plus Vm square plus 2 Vr Vm cos 90 is 0. So ultimately we are getting relative velocity of rain with respect to man is equal to square root of Vr square plus Vm square, and this is the magnitude of relative velocity. So this formula we need to use in order to solve the numerical in connection to rain-man problem. Now it's time to know about the angle with which the man should hold his umbrella with respect to the vertical in the direction of his motion in order to protect himself from rain. So this one can be calculated from this triangle OAB, let it be C. Now from triangle OAB we get tan theta is equal to AB by OB is equal to OC by OB. Since OC and AB both are same, what is OC? Mod minus Vm vector, and what is OB? This is mod Vr vector. So after solving we get theta is equal to tan inverse Vm by Vr. From here we can see if the man is at rest, if the man is at rest, that is if Vm equal to 0 meter per second, theta is equal to 0 degree. So what does it represent? It simply represents that when the person or the man is at rest or not moving at all, then he has to keep his umbrella vertically so that he can protect himself from rain. If the man increases his velocity, what will happen? If Vm increases, this ratio will increase. On increasing this ratio, the angle will also increase. That is, with more and more angle, the man should keep his umbrella in the direction of his motion in order to protect himself from rain. Understood? In this question, it has been given that rain is falling vertically downward with a speed of 25 meter per second. This sign we have considered as vertical direction. This is top and this is bottom. And the velocity of rain is 25 meter per second. In the second line, it is given that a bicyclist is going at a speed of 10 meter per second in west to east direction. West to east. So bicyclist's speed is 10 meter per second from west to east. Now we have been asked to find the apparent speed of rain and its direction with respect to the bicyclist. So from the definition of relative velocity, we can write apparent speed of rain with respect to bicyclist, that is relative velocity of rain with respect to bicyclist is equal to actual velocity of rain minus actual velocity of bicyclist. That can also be written as VR plus of minus VV. So let's identify minus VV in the diagram. This is minus VV, and to find VRB we need to find the resultant of VR and minus VV. So we have to complete this rectangle. After that we have to draw the diagonal. This diagonal will show us the resultant of minus VB and VR, and this resultant will provide us the apparent velocity of rain with respect to bicyclist, and the direction of this apparent velocity will be at an angle of theta with respect to vertical. What is the angle between this minus VV and VR? This is 90 degree. This angle is theta because these two angles are vertically opposite angles. Say this point is A, this point is B, and this point is C. So now mod VRB is equal to root over of VR square plus VB square plus 2 VR VB cos 90. Cos 90 is the angle between minus VB and VR. So on solving we will get VR square plus VB square. This minus will be gone as it is within the mod. So 25 square plus 10 square. 25 square is 625 plus 100. You will get 725. If you solve it, you will get what? 5 root over 29 meter per second. This is the relative velocity or apparent velocity of rain with respect to bicyclist. Now the direction of this apparent velocity can be calculated from this triangle OBC. From the triangle OBC we can write tan theta is equal to BC by OB. This is what? BC is equal to what? BC equal to OA by OB. Now what is OA? OA is equal to minus VB, that is mod minus VB, that is 10, and OB is equal to mod VR, that is 25. 10 by 25 is 2 by 5. So theta we will get as tan inverse 2 by 5 with respect to vertical. This angle will be with respect to vertical. Remember this. This is the direction of the apparent velocity of rain with respect to the bicyclist. So our result will be 5 root over 29 comma tan inverse 2 by 5 with respect to vertical. This is option D. In this question it is given that a man is walking on a road with a speed of 3 km per hour, and he finds that the rain is falling vertically downward, okay, when he increases his speed to 6 km per hour, the rain appears to meet him at an angle of 45 degree with the vertical. Find the speed of the rain. So first of all, we are going to assume the speed of the rain as say a I cap plus b j cap. What are I cap and j cap? These are the unit vectors along x-axis and y-axis. Y-axis we are considering as vertical direction, and this is j cap, and x-axis we are considering as horizontal direction, and the road is present along horizontal direction. So according to the question, the velocity of the man is 3 I cap in the first case, and what will be the apparent velocity or relative velocity of rain with respect to man? This will be Vr minus Vm. Put the value of Vr, a I cap plus b j cap minus Vm. This is 3 I cap. So if you solve it, you will get a minus 3 I cap plus b j cap. Now as per the question, this will be along vertical direction. See, the rain appears to fall vertically downwards. When the speed of the man is 3 km per hour, he finds that the rain is falling vertically downward. So the relative velocity of rain with respect to man should contain only the component along the vertical direction. There should not be any component in the relative velocity of rain with respect to man in horizontal direction, because it is given the vertically downward direction. The man is finding the rain to fall. Okay, therefore a minus 3 should be 0. This is according to question. So from here we are getting a is equal to 3. This will be kilometer per hour. Speed of the man in the second case, it becomes 6 I cap, and again we have to find the relative velocity of rain with respect to man. Let it be 2 and it be 1. So it will be Vr minus V2. This will be a I cap plus b j cap minus V2 will be 6 I cap. So you solve it, you will get a minus 6 I cap plus b j cap. And according to the question, this time the rain appears to fall at an angle of 45 degree with the vertical. That is, Vrm2 vector is making an angle of 45 degree with this unit vector j cap. So we can write, according to question, Vrm2 dot j cap is equal to mod Vrm2 mod j cap cos 45 degree. This is the definition of dot product. Okay, now mod Vrm2 will be square root of a minus 6 whole square plus b square. Mod j cap will be 1, and cos 45 degree will be 1 by root 2. Okay, and here you put the value of Vrm2, a I cap plus b j cap dot j cap. So I cap dot j cap is 0, j cap dot j cap is 1. Okay, j cap dot j cap is 1. So from here you can write b is equal to square root of a minus 6 whole square plus b square divided by root 2. Squaring both sides, we get b square equal to a minus 6 whole square plus b square by 2. Then we will get what? 2b square is equal to a minus 6 whole square plus b square, implies b square is equal to a minus 6 whole square. Now what is a? Give it equation number 1. According to equation 1, A is 3. So we will get b square is equal to 3 minus 6 whole square, that is equal to 9, implies b equal to 3 kilometer per hour. So the velocity of rain will be what? Vr vector is equal to a I cap, means 3 I cap plus 3 j cap, implies speed of the rain, that is magnitude of velocity of the rain, will be root over of 3 square plus 3 square is equal to 3 root 2 kilometer per hour. Here it is given that the rain is falling at an angle of 53 degree with respect to the vertical with a speed of 40 kilometer per hour, and a man is moving with a speed of 50 kilometer per hour along a horizontal road. We are to find the apparent velocity, that is the relative velocity of rain with respect to man. Relative velocity of rain with respect to man, this one we need to find. And also we are to find the direction along which the man has to keep his umbrella in order to protect himself from rain, that is the direction of VRM, relative velocity of rain with respect to man, also to be obtained. Now we consider the vertical direction along y-axis and horizontal direction along x-axis. This is horizontal and this one is vertical direction. Okay. Now according to question, the man is moving at a speed of 50 km per hour along a horizontal road, and the rain is falling at an angle of 53 degree with respect to vertical. So this direction will represent the actual direction of motion of the rain, and this one is 40 km per hour. Now the component of actual velocity of rain along vertical direction will be Vr cos 53 degree, and that along horizontal direction will be Vr sin 53 degree. Now sin 53 degree and cos 53 degree can be obtained from this triangle 5 4 3. This one is 53 degree, this angle is 37 degree. So from this triangle we can write cos 53 is 3 by 5 and sin 53 is 4 by 5. So what is VR? VR is 40 km per hour. 40 into 3 by 5, that is equal to 24 km per hour, and here it will be 40 into 4 by 5, that is equal to 32 km per hour. Now the unit vector along positive x-axis is I cap and unit vector along negative y-axis is minus j cap. So actual velocity of rain can be written as Vr vector equal to 32 I cap minus 24 j cap, and actual velocity of man can also be written as 50 I cap, because the man is moving along horizontal direction and the horizontal direction is chosen along positive x-axis. So by definition of relative velocity of rain with respect to man, we can write Vrm vector equal to Vr vector minus Vm vector. What is Vr vector? 32 I cap minus 24 j cap minus 50 I cap. So if we solve this, we will get minus 18 I cap minus 24 j cap. So the magnitude of relative velocity of rain with respect to man will be square root of minus 18 whole square plus minus 24 whole square, that is equal to square root of 900 is equal to 30 km per hour. Now to find the direction of relative velocity of rain with respect to man, we have to express this vector with the help of two-dimensional coordinate system. Suppose this one is our x-axis, this is our y-axis, this will be negative x-axis, this will be negative y-axis. The unit vector along negative x-axis is minus I cap and that along negative y-axis is minus j cap. Now the component of relative velocity of rain with respect to man along negative x-axis is 18 km per hour, and that along negative y-axis is 24 km per hour. Say this one is 18 km per hour and this one be 24 km per hour. Okay, now our VRM vector will be this one, VRM vector. Let alpha be the angle made by the apparent velocity of rain with respect to man with the vertical direction. So this one will be again alpha. We consider this point is O, this point is A, this one is B, and this point is C. So if we consider this triangle OAB, we can write tan alpha is equal to, this is perpendicular and this one is base, AB by OA. Now what is AB? This one is a rectangle. AB is equal to OC because these are two opposite sides. So OC by OA. Now what is OC? OC is 18 km per hour and OA is 24 km per hour. If we solve it, we will get 3 by 4. From this triangle, we can write tan 37 degree is equal to 3 by 4. So in place of 3 by 4, we can write tan 37 degree, and this is equal to tan alpha. So on solving, we are getting alpha is equal to 37 degree. So we can say that the man should hold his umbrella at an angle of 37 degree with respect to vertical in order to protect himself from rain. This numerical is quite similar to the previous one. Here it is given that the rain is falling with a speed of 60 meter per second, making an angle of 37 degree with the vertical direction, and the man is moving with a speed of 30 meter per second, and the inclined surface is making an angle of 37 degree with respect to the horizontal direction. Now the vertical direction is chosen along y-axis and horizontal direction is chosen along x-axis. Now we have been asked to find the apparent velocity of rain with respect to man and also the direction along which the rain will appear to fall with respect to the man. To find the apparent velocity of rain with respect to man, first of all we have to express VR vector and VM vector with the help of their rectangular components. So what will be the component of VM vector along x-axis? It will be 30 cos 37 degree, and that along positive y-axis will be 30 sin 37 degree. Similarly, the component of VR vector along negative x-axis will be 60 sin 37 degree, and that along negative y-axis will be 60 cos 37 degree. Now to find the values of sin 37 and cos 37 degree, we have to take the help of an identity triangle. This is 5, 4, 3, 37 degree angle. Okay, so from this triangle we can write cos 37 degree is equal to 4 by 5 and sin 37 degree is equal to 3 by 5. So 30 cos 37 degree can be written as 30 multiplied by 4 by 5 is equal to 24, and 30 sin 37 degree can be written as 30 into 3 by 5 is equal to 18. 60 sin 37 degree can be written as 60 into 3 by 5 is equal to 36. 60 cos 37 degree can be written as 60 into 4 by 5 is equal to 48. So VR vector can be written as 36 minus I cap plus 48 minus j cap. This is equal to minus 36 I cap minus 48 j cap, and VM vector is equal to 24 I cap plus 18 j cap. Now apparent velocity of rain with respect to man can be written as VR minus Vm. This is equal to minus 36 I cap minus 48 j cap minus 24 I cap plus 18 j cap. On solving we will get minus 60 I cap minus 66 j cap implies mod VRM, that is magnitude of apparent velocity of rain with respect to man, is equal to square root of minus 60 whole square plus of minus 66 whole square. On solving this, we will get approximately 89.2 meter per second. Now to find the direction along which the rain will appear to fall with respect to the man, that is, to find the direction of relative velocity of rain with respect to man, we need to express VRM vector with the help of two-dimensional coordinate system. This is our x-axis, this is our y-axis, this is negative x, this one is negative y. Unit vector along negative x-axis is minus I cap, and that along negative y-axis is minus j cap. Now component of VRM vector along negative x-axis is 60 meter per second, and that along negative y-axis is 66 meter per second. Now the vector obtained by this rectangular component 60 meter per second along negative x-axis and 66 meter per second along negative y-axis, we will get the relative velocity of rain with respect to man, and this will be the diagonal of this rectangle VRM vector. Say this VRM vector is making an angle alpha with the vertical direction. Suppose this point be O, this one be A, this one is denoted by B, and this one is C. From triangle OAB, we can write tan alpha is equal to AB by OA. Now what is AB? AB is exactly equal to OC, and OA will remain as it is. Now what is OC? OC is 60 meter per second, and what is OA? It is 66 meter per second. On solving this, we will get 10 by 11. So alpha will be tan inverse 10 by 11. This is the angle along which the rain will appear to fall with respect to the man moving along the inclined surface. Here it is given that a man standing on the road has to hold his umbrella at an angle of 30 degree with respect to the vertical, so that he can keep himself out of the rain. So what will be the actual direction of the rain? This will be 30 degree with respect to the vertical. Now he throws the umbrella and starts running at 10 km per hour, finds that the raindrops are hitting his head vertically. So the apparent direction of motion of the rain with respect to the man, as the man starts his motion, should be along the vertical direction. Understood? We have been asked to find the speed of raindrops relative to the ground, that is actual velocity of raindrop we need to find. Okay, so let's draw the diagram. Suppose this is the horizontal direction, and this one is representing the vertical direction. Initially the rain is falling at an angle of 30 degree with respect to the vertical. Let VR be the actual velocity of rain with respect to the ground. Okay, now we choose x-axis along the horizontal direction and y-axis along the vertical direction. So this one will be negative y-axis, this one will be negative x-axis. Now this angle will be 30 degree because these two are vertically opposite angle. Now the components of VR vector along negative x-axis and negative y-axis will be VR by 2. Let it be VRX, means x component of actual velocity of rain, and y component of actual velocity of rain will be VR cos 30 degree. This is equal to root 3 VR by 2. Now the unit vectors along negative x-axis is minus I cap, and that along negative y-axis is minus j cap. So we can write VR vector is equal to VR by 2 minus I cap plus root 3 VR by 2 minus j cap. This is equal to minus VR by 2 I cap minus root 3 VR by 2 j cap. Now the man starts running at a speed of 10 km per hour, finds that raindrops are falling vertically downward. So this will be the direction of relative velocity of rain with respect to man. Now we need to identify in which direction, that is towards right or towards left, the man should run, so that the relative velocity of rain with respect to man comes along vertically downward direction. We know the relative velocity of rain with respect to man, that is Vrm is equal to Vr minus Vm. This equation can also be written as Vrm vector is equal to Vr vector plus minus Vm vector. From this equation we can say that Vrm vector should be the resultant of Vr vector and minus Vm vector. So if we consider our minus Vm vector along x-axis, we will get one parallelogram, say O, A, B, C, the diagonal of which will provide us Vrm vector. So now you think, what should be the actual direction of motion of the man? This should be towards negative x-axis. So what will be the unit vector in the expression of Vm vector? This will be minus I cap and its magnitude will be 10 km per hour. Okay, so we can write Vm vector equal to 10 km per hour is the magnitude, and the direction is minus I cap, that is along negative x-axis. This is equal to minus 10 I cap. Therefore apparent velocity of rain with respect to man is equal to Vr vector minus Vm vector. This is equal to minus Vr by 2 I cap minus root 3 Vr by 2 j cap minus of minus 10 I cap. This is equal to 10 minus Vr by 2 I cap minus root 3 Vr by 2 j cap. Now from the diagram we see that Vrm vector is making an angle of 90 degree with positive direction of x-axis, that is with plus I cap. So we can write Vrm vector dot I cap, this is equal to mod Vrm vector mod I cap cos 90 degree, this is equal to 0, implies Vrm vector dot I cap is equal to 0, implies what is Vrm vector? This one, 10 minus Vr by 2 I cap minus root 3 Vr by 2 j cap whole bracket dot I cap is equal to 0. But we know the property of dot product, I cap dot I cap equal to 1 and j cap dot I cap is equal to 0. Now if we apply these properties here, we will get what? I cap dot I cap, this will provide us 1 and j cap dot I cap will provide us 0. So we will get 10 minus Vr by 2 is equal to 0, implies Vr by 2 is equal to 10, implies Vr is equal to 20 km per hour. This is the velocity of rain with respect to the ground. Okay, those who have understood the previous numerical, they can easily solve this, because this numerical is almost similar to the previous one. Here it is given that a man standing on a horizontal road has to hold his umbrella at an angle of 60 degree with respect to the vertical in order to keep himself away from rain. As the man starts moving with a speed of 5 meters per second, he finds that the same rain appears to fall with respect to the vertical at an angle of 30 degree. Now here we have been asked to find the actual velocity of rain, that is the velocity of rain with respect to the ground. So let's draw the diagram. Suppose this direction is vertical direction and this direction is horizontal direction. X-axis is chosen along horizontal direction and y-axis is chosen along vertical direction. This one will be the negative y-axis and this one is negative x-axis. In this question it is mentioned that the person should hold his umbrella at an angle of 60 degree with respect to the vertical. So from here only we can guess that the actual direction of motion of the rain will be 60 degree with respect to the vertical. Okay, so our actual direction of motion of the rain will be this one, 60 degree with respect to the vertical. Let the actual velocity of rain be VR vector. Okay, as the person starts moving, he finds that the rain appears to fall at an angle of 30 degree with respect to the vertical. So this one will be the apparent velocity of rain with respect to man. So the direction of apparent velocity of rain with respect to man when the man is in motion is this one, VRM, and this angle is 30 degree as it is mentioned in the question. This angle will be 60 degree because these two angles are vertically opposite angles. Okay, now we need to identify the actual direction of motion of the man, whether the man will move towards left or towards right, just like the previous numerical. We will write down the expression for relative velocity of rain with respect to man. It will be VR minus VM. This is equal to VR plus minus VM. We have to keep minus Vm vector along x-axis so that the resultant of minus Vm and Vr comes along Vrm, because the resultant of Vr and minus Vm is Vrm vector. Vrm means relative velocity of rain with respect to man. Okay, so if this one is represented by minus Vm, now what will be the direction of Vm? This will be along negative x-axis. So unit vector chosen along negative x-axis is minus I cap, that one we know, and that along negative y-axis is minus j cap. So the actual velocity of man will be 5 meter per second, and this is along negative x-axis, so it will be 5 minus I cap. This is equal to minus 5 I cap. Now we have to express VR vector with the help of its rectangular components. So the component of VR vector along negative x-axis will be VR sine 60 degree, because this angle is 60 degree. This will be root 3 VR by 2, and that along negative y-axis will be VR cos 60 degree. This is equal to VR by 2. So VR vector can be expressed as root 3 VR by 2 minus I cap plus VR by 2 minus j cap equal to minus root 3 VR by 2 I cap minus VR by 2 j cap. So from this equation we can write relative velocity of rain with respect to man is equal to VR vector minus Vm vector is equal to minus root 3 VR by 2 I cap minus VR by 2 j cap minus Vm vector. Vm vector is minus 5 I cap, minus 5 I cap. So on solving this we will get 5 minus root 3 VR by 2 I cap minus VR by 2 j cap. Give it equation number 1. Now from the expression of apparent velocity of rain with respect to man, we see that it has two components. One is along negative x-axis and another is along negative y-axis, and hence VRM vector can be expressed with the help of two-dimensional coordinate system. This is x-axis, this one is y-axis, this one is negative x-axis, this one is negative y-axis. Unit vector along negative y-axis is minus j cap, unit vector along negative x-axis is minus I cap. This root 3 VR by 2 minus 5 is representing the component of VRM vector along negative x-axis. Say this much portion is representing root 3 VR by 2 minus 5, root 3 VR by 2 minus 5, and this one is representing VR by 2. VR by 2. The vector obtained from these two components is nothing but our VRM vector, that is apparent velocity of rain with respect to man, and this vector is given by the diagonal of this rectangle OABC. Now from this diagram we see that VRM vector is making an angle of 30 degree with the negative y-axis. So this angle will be 30 degree. Okay. Now if we consider the triangle OAB, we can write tan 30 degree is equal to perpendicular AB by base OB. AB by OB. Now what is AB? AB is equal to OC. AB equal to what? OC. And OA will remain as it is. This is equal to root 3 VR by 2 minus 5 divided by VR by 2. And what is tan 30 degree? 1 by root 3 implies 1 by root 3. Now from this line we will get 1 by root 3 is equal to, so in the numerator we can do LCM, root 3 VR minus 10 divided by VR by 2. This equal to root 3 VR minus 10 divided by VR. Now you cross multiply, you will get VR is equal to 3 VR minus 10 root 3. What is the value of root 3? 1.732 multiplied by 10, it will be 17.32. 3 VR minus 17.32 implies minus 2 VR is equal to minus 17.32 implies VR is equal to 17.32 divided by 2. This is equal to 8.66 meter per second.